Hello, this is Kapil Sharma, and this is ICP09 submission for big data analytics. Objective for this ICP09 is to create a linear regression model and then take any data set and to fit over it and then calculate sum of square errors, mean square errors, y-intercept, and slope of the that relationship. So imported all the required libraries, imported sklearn machine learning and linear regression for linear regression model, uploaded data set. So this data set advertising.csv, this is very popular data set available on Kaggle. We discussed this in ISLR book also, ISLR subject, and this data set is depicting the relationship between TV, radio, and newspaper over the sales of any product. So this is having four columns. TV, radio, newspaper are the dependent variables, and sales is uh, uh, independent variable. So we will be predicting sales using this regression model. Displaying five records for this one using head, shape of the data set, having 200 columns, 200 rows, 4 columns, printing data about it. So we can see like non there are no this is null count is like non-null, data type is float, and there are 200 rows. Now data dot describe for displaying the statistical values, count, mean, standard, mean, max values, and checking the null values. As we already saw, there are no null values, there are no rows. So now plotting sales versus TV, newspaper, and radio. So using Seaborn SNS and Matplotlib, plotting here. So you can see this is forming a linear regression, a linear relationship, whereas these are the scattered ones and are not giving a strong linear relationship. Okay, so we will use sales and TV for this linear relationship. Now plotting the correlation heat map. So you can see like sales and TV is having a correlation, positive correlation, strong correlation of 0.9, whereas sales and radio is 0.35 and sales and newspaper is 0.16. Okay, so that's why we will fit a linear model using TV and sales. TV as feature and sales as output. So now storing dependent and independent variable x and y. X is having data as TV and the y is sales. Model linear regression. Now let's fit the model using our data, and here printing the intercept and slope of the model. So intercept is 6.97 something, and slope of the model is 0.0555. So now let's represent the linear regression. So linear regression is kind of y equal to b beta 0 plus beta 1 x, where beta 0 is the intercept and beta 1 is the slope. So that's why sales, y is sales, sales equals to the intercept, sorry, slope into TV plus intercept. Okay, so predicted value is ypred, and predicting and using model.predx. Now plotting the regression line. So you can see this is sales and TV, sales versus TV, displaying the regression linear relationship. Now calculating the R squared. So R squared is indicating coming as 0.812. So that is like 81.22%. So it indicates like 81.22% of the variance in sales is explained by TV. Okay, now calculating the mean squared value and sum squared value using the formula. And so SSE is coming as 1043, whereas MSE is coming as 5.21. So MSE is like how close a regression line is to a set of the points. So That's why we want to make sure, like, for better forecasting or better predicting, MSC should be minimum. Okay, the lower the MSC, better will be the prediction. Some of the square error is just the difference between observed values and the predicted values. So that error we will be squaring and then summing it up. So that is the total value. Okay, so that should also be less for a better model, linear regression model. Thank you.